This is SpaceTime Series 24, Episode 31, for broadcast on the 22nd of March 2021. Coming up on SpaceTime, countdown for Australia's return to orbit, are interstellar visitors more common than we thought? And NASA's Hubble Space Telescope back in operations after an emergency shutdown. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
If all goes according to plan, in almost exactly a year from now, Australia will officially become a spacefaring nation. Again. Of course, back in the 1960s, the Woomera rocket range in outback South Australia was one of the busiest spaceports in the world, second only to Cape Canaveral in Florida. And on October the 29th, 1967, Australia became only the fourth nation on Earth to launch a satellite it built into orbit from its own soil, when the scientific spacecraft RESAT-1 blasted off from Space Launch Complex LA-8 at Woomera. But with a lack of foresight and vision that would leave most people stunned, Australia's dim-witted politicians, squabbling amongst themselves and only ever seeing as far as the next election, decided there was no future in space. And that's a direct quote. Now, remember, this was at the very height of the space race. The satellite communications industry was already growing into a multi-billion-dollar giant, shining a beacon on the path to the future. There's no benefit of hindsight here. It was clear to everybody at the time, except, it seems, Australia's elected representatives. And the level of stupidity in Australia's politicians is really quite mind-blowing. Not only did they turn down an offer for Australia to become one of the founding members of the then-fledgling European Space Agency, but the government also sold off most of the technology and infrastructure which had been painstakingly developed at Woomera for scrap value. It's taken over half a century, but Australia is finally getting back in the saddle with the creation of an official Australian space agency, and new spaceports being developed for NASA by Equatorial Launch Australia in the Northern Territory's Arnhem Land in Nhulunbuy, and another company, Southern Launch, commencing missile test flights at the Canimba rocket range near Ceduna and developing its own orbital launch complex at Whalers Way near Port Lincoln. Meanwhile, Gold Coast company Gilmore Space Technologies is developing its own orbital launch vehicle, the Ares 1. It's slated to carry the Optimus 1 orbital transfer module and its Fireball International satellite payload into space in March next year. Fireball is designed to provide automated early detection and tracking of wildfires using artificial intelligence, allowing quicker response times by firefighters. Mounting the system aboard a spacecraft will cut the time from ignition to detection of fires down to under 3 minutes over a vast range. It'll also be able to see through the smoke to locate the actual seat of the fire, thereby providing more accurate targeting for firefighting aircraft. The technology used by Fireball was originally designed to look for supernova explosions in deep space. But Fireball turns that technology upside down, looking downwards for fires, specifically focusing on early smoke emissions. Each year the Fireball system analyses around 1 million images, half from satellites, and it uses artificial intelligence to quickly identify new smoke plumes. The Sunshine Coast-based company's already secured several US contracts to monitor around 50 million hectares for wildfires. In fact, during the 2020 California wildfire season, Fireball detected and confirmed more than 850 fires, with around 65% detected within a minute, 95% within 5 minutes, and 100% within 10 minutes. The company's planning to develop a constellation of 24 satellites by 2028, either as individual spacecraft or as payloads on other satellites. Fireball's CEO, Christopher Tyler, says the technology is already tried and tested.
What we do is we provide information to fire emergency services which help them to attack fires more efficient. We do that from detection, even a little bit further, from determination what the fuel is on the ground over detection, up to the mop-up and fire severe assessment afterwards. For that, we have developed a range of systems on our core products in artificial intelligence. Actually, it's a series of algorithms. It's actually a system of systems which get data fed from different sources. So one of these sources is a ground-based camera network, which detects fires by looking for smoke in images, and we call that Fuego Ground. The other one is Fuego Space, which is a range of satellites which are owned by and operated by international space agencies, but we are planning to build our own and launch that by 2022. The third part is Fuego Air, which is a sensor array that's mounted on airplanes, drones, helicopters, etc., to fire mapping if a fire gets out of control. So the whole system detects a fire within 1 to 3 minutes. So we are looking for smoke. And when we started out this journey, it was actually quite funny because I said, hey, come on. We are able to pick a face out of the crowd in a stadium. How hard can it be to detect smoke in the landscape? Turned out it's much, much harder than picking out a face in the crowd in the stadium. But we are not using infrared on the ground. We are using infrared in the satellite. The satellite spots for heat signatures, and the ground-based looks for smoke. Right now, we're using satellites provided by NOAA. That's the GHOST satellite for California.
Yep.
We have a system up and running in California where about 900 cameras, 1,000 cameras feed into the system and detect fire and use the GHOST satellite to spot the fire on the ground. And all of that is represented on Google Maps.
And how small a fire can you see from there?
About the size of a lorry, of a truck, of a garden shed. We use the ground-based and the space-based in unison. So either the one or the other picks it up and then it gets confirmed. What we don't want to do is we do not want to get out false positives to the emergency services. So we have a system of systems to eliminate false positives. The two satellites I mentioned before are geostationary satellites. So they're looking at the same spot over the planet all the time. They are synchronized with the spin of the planet. But we need, in terms of mapping, a little bit more information. So we are also using low Earth orbit satellite. We are planning to launch our own by 2022 and put up a constellation which is dedicated for fire. So far, the satellites up there are kind of a compromise. You know, they are a jack of all trades. We want to have one which is dedicated to fire and look especially for the wavelengths we need to have.
Right now you're using GOES, you're going to be using the Sentinel satellites from the European Space Agency, you're using the Japanese weather satellite as well.
Yeah, and MODIS and everything, Landsat, everything you can imagine, which has a sensor on board which we can use. We plan to launch a range of satellites. The first one, which is dedicated to look over Australia, we are in negotiation with a telecom company who launches a telecom satellite by 2025, and we want to have a hosted payload on there. This communication satellite is really good for us because it has communication and power already there, and we just put out on our, we have a piggyback ride on this satellite with our instrument. And this one goes up about 40,000 kilometers in geostationary orbit. But we also plan low Earth orbit satellites, which have a much better resolution than about 500, 600 kilometers altitude. And we plan to launch that by 2022. That will be a complete constellation between 24 and 48 satellites.
And these will be what, CubeSats?
That's not decided yet. The first one we launch is in collaboration with Australian National University. They look at the fuel load on the ground. We look at the fire mapping. That will be a 12-unit CubeSat, but we are looking for a bigger platform right now, and we are in discussions with a provider. Also, actually, funny story, also an Australian provider who plans to create a new satellite bus, which would absolutely fit our purposes.
Not a CubeSat.
It will be a proper size satellite, yeah.
You're going to need something reasonably big to launch that then. You wouldn't be able to launch it on an Electron.
Yes, we are in negotiation with SpaceX. The satellite bus I'm talking about has a base length of 30 centimeters. So we are talking about having one 60 by 60 centimeters. That still can be launched by a local provider like Gilmore, for example, on the Aries.
So that'll be within 300 kilograms in weight then?
Yes, I'm an astrophysicist. So if you break it down, it's a telescope which looks downwards.
Yeah.
So we have a 60 centimeter mirror in there, and then the sensors, onboard edge computers, communication, guidance, a little bit propulsion.
How far along are you in the development of the satellite?
Actually, far ahead. The whole satellite development was started, one of our founders, Professor Carl Pennypacker, he is at UC Berkeley. He studied explosion in supernovas in far distant galaxies years ago. And then there was a big fire in his neighborhood where two of his neighbors' houses were completely destroyed. So he was thinking, the technology I have developed here, looking outwards to space to find explosions in millions of light years away galaxies, can help to look downwards, because the same methodology, looking for this small signal and a lot of noise, can be used in fires. So he started to develop at UC Berkeley together with the SSL technology. So to answer the question, we are quite far ahead. We are also collaborating with the Australian National University, with Marta Yebra leading that, where they are looking at moisture content and food content on the ground to determine when the fire starts, how will it develop in the next half an hour or so, to give this information to the fireys. And that is a very important information.
And what sort of a lifespan will one of these satellites have? Have you worked that out yet? Is it purely the amount of fuel it can carry?
No, it's the orbit they are in. These little buggers are in a very low orbit. We think 3 to 5 years is the lifespan of those.
And you're talking about quite a constellation.
Yes, we're talking about 24 to 48 satellites up there.
That's Chris Tyler, the CEO of Fireball International. And this is SpaceTime. I'm Stuart Gary. Still to come, a new study suggests interstellar visitors are more common than we thought. And NASA's Hubble Space Telescope experiences an emergency shutdown. All that and much more still to come on SpaceTime. A new study suggests around 7 interstellar visitors pass through our solar system every year. The findings, reported on the pre-press physics website archive.org, are based on detailed calculations combining observations of existing interstellar visitors and data from the European Space Agency's Gaia mission. Launched in 2013, Gaia is developing a three-dimensional map of nearby space by measuring the positions, distances and movement of over 1 billion stars, planets and other celestial objects, including asteroids and comets. Back in October 2017, astronomers confirmed the detection of Maui, our first confirmed interstellar visitor. A weird, flat, elongated asteroid whose orbital path indicates that it didn't originate in our solar system and was already on its way back out again. Then just 2 years later, astronomers detected a second interstellar visitor, the alien comet Borisov, also by its hyperbolic orbital trajectory, indicating its origin and destination were well beyond our solar system. If there was any doubt, Borisov confirmed what many astronomers had already suspected, that interstellar objects enter our solar system on a pretty regular basis, drawn in by the sun's enormous gravitational pull, only to be flung out again. A team of researchers from the Initiative for Interstellar Studies wanted to determine just how often this occurs as part of proposals to send a spacecraft to rendezvous with and study one of these interstellar objects in order to provide astronomers with insights into their home systems and the different regions of space they've travelled through on their journey so far. There are several different proposals on the drawing boards. These include interceptor missions spotting an interstellar object early enough to launch a spacecraft to undertake a flyby. Others involve pre-positioning small probes in the outer solar system, then simply waiting for an interstellar object to arrive nearby and then closing in for a detailed examination. To place better constraints on these options, the study's authors wanted to know how often these long-distance visitors would be passing through. Their calculations show that up to 7 interstellar asteroids like a Maui are likely to pass through our solar system every year, and many of these objects will be moving faster than the 26 kilometres per second Maui was travelling at. Meanwhile, they suggest that an interstellar comet like Borisov would swoop through our solar system roughly every 10 to 20 years. This is SpaceTime. Still to come, the Hubble Space Telescope suffers an emergency shutdown, and discovering a monster on the move. All that and more coming up on SpaceTime. NASA's Hubble Space Telescope's back online after suddenly shutting down last week due to a software error in the orbiting observatory's main computer. The spacecraft went into an emergency safe mode when the problem surfaced. Safe mode puts the telescope into a stable configuration until solutions can be implemented by mission managers back on the ground. The team at NASA's Goddard Space Flight Center identified the software error in an enhancement recently uploaded to the telescope in order to help compensate for fluctuations from one of its gyroscopes. Gyroscopes are used to help Hubble turn and lock on targets by measuring the speed at which the spacecraft's turning. The team at Goddard determined that the enhancements that were uploaded didn't have permission to write to a specific location in one of Hubble's computer memory banks. This caused an issue with the main flight computer and subsequently caused the spacecraft to enter a safe mode. Once the problem was identified and resolved, Hubble's onboard systems were able to begin to return to normal operations. However, then a new problem developed with Hubble's Wide-Field Camera 3 instrument. It refused to turn on. Wide-Field Camera 3 is one of the key scientific instruments used by astronomers, so it's kind of important to have it operational. It seems after starting its recovery, the instrument suddenly suspended the process due to a lower than normal voltage reading for a power supply, which then in turn triggered an internal instrument safeguard. Mission managers say that happened because the electronics experienced colder temperatures when the hardware is turned off in safe mode. This factor, coupled with the additional power which the instrument's components draw as they turn back on, all combined to contribute to a voltage fluctuation which in turn suspended recovery operations. Further analysis by the team at Goddard quickly determined that it would be safe to fire up the system using a slightly reduced voltage, which was then done, bringing Wide-Field Camera 3 back into service, much to the relief of many astronomers. This is SpaceTime. Still to come, discovering a monster on the move. And later in the science report, ethical controversy erupts after scientists generate a copy of a human embryo from skin cells. All that and more coming up on SpaceTime. Astronomers have discovered a supermassive black hole moving through the universe. Supermassive black holes are among the most powerful objects known, and the idea of them gallivanting around through the cosmos is quite unsettling. They're usually found at the centres of most, if not all, galaxies. Scientists have long theorised that it would be possible for supermassive black holes to wander through space, but no one's actually ever found one. Until now. A report in the Astrophysical Journal claims the supermassive black hole at the heart of the galaxy J0437 plus 2456, located some 230 million light-years away, is moving at a different velocity compared to the galaxy it's in. The study's lead author, Dominic Pesce from the Harvard-Smithsonian Center for Astrophysics, says astronomers don't expect the majority of supermassive black holes to be moving. They're usually just content to sit around. But this is the clearest case to date of a supermassive black hole in motion, and that implies that the black hole's been disturbed by something. The authors discovered this 3 million solar mass monster on the move during a survey of 10 distant galaxies. They were specifically looking for black holes that contained water within their accretion disks, the rings of material being torn apart prior to that material falling into the black hole. As the water orbits around the black hole's accretion disk, it produces a laser-like beam of radiolight known as a maser. When studied with a combined network of radio antennas using a technique known as very long baseline radio interferometry, masers can be used to help measure a black hole's velocity very precisely. The technique helped the authors determine that 9 of the 10 supermassive black holes they were studying were at rest, quietly sitting in the middle of their host galaxies. But one stood out, because it seemed to be in motion. Follow-up observations using the Arecibo and Gemini observatories confirmed the initial findings. It seems this supermassive black hole, as big as the one at the centre of our own galaxy, is moving at around 180,000 kilometres per hour compared to the galaxy it's in. Now, this movement could be caused by the merging of 2 supermassive black holes, causing the newly formed larger black hole to recoil as it settles down again. Or the black hole may simply be part of a binary system with an as-yet undiscovered companion. The authors say that would be an exciting prospect, because despite every expectation that they ought to be out there in some abundance, astronomers have had a hard time identifying any clear examples of binary supermassive black holes. So, what astronomers could be seeing in the galaxy J0437 plus 2456 is one of the black holes in such a binary, with the other remaining hidden because of its lack of maser. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists at Monash University have produced a model of a human embryo out of human skin cells without using a fertilized human egg. The team, led by Jose Polo, successfully reprogrammed human fibroblasts, the main type of cell found in connective tissue, to develop into a three-dimensional model of a human blastocyst, the stage that the human embryo reaches 5 to 6 days after fertilization. Scientists say, although similar, these human blastocyst-like structures, called induced blastoids, can't develop into a human fetus or baby, but they could be used to produce pluripotent or trophoblast stem cells. Meanwhile, a separate study by Jun Wu and colleagues at the University of Texas were able to generate blastocyst-like structures which they call human blastoids from human pluripotent stem cells. The human blastoids resemble human blastocytes in their morphology, size, cell number and composition. The authors found they were able to generate embryonic and extra-embryonic stem cells which could self-organize into structures capable of developing in vitro in a fashion that mimicked the growth and differentiation of an embryo after implantation into the womb. The two breakthroughs, reported in separate articles in the journal Nature, provide models for studying early human development, new in vitro fertilization techniques, and provide insights into early developmental defects. A new study has found that the UK variant of the COVID-19 coronavirus is linked to an increased risk of death. A report in the journal Nature claims the UK or B117 strain shows a 55% increased risk of death compared to other variants. Scientists analysed almost 5,000 deaths in England with confirmed infections with the variant. It means the absolute risk of death for a 55 to 69-year-old male increases from 0.6 to 0.9% within a month after testing positive for the variant. Over 2.7 million people have now died from the COVID-19 virus, with another 121 million having been infected since the virus first emerged from Wuhan, China, and spread around the world. A new study claims lightning strikes may have supplied enough of the essential phosphorus compounds to support the first life on Earth. Previously, it was thought that the phosphorus required to make the first DNA, RNA and cell membranes came from a mineral called schreibersite, which is most commonly found in meteorites. However, a report in the journal Nature Communications claims schreibersite within glassy minerals can be formed by lightning strikes hitting clay-rich soils. Scientists say modelling and simulations determined that this process could have produced enough schreibersite to kick-start early life on Earth. Paleontologists have unearthed the world's first example of a fossilised dinosaur sitting on a nest of eggs. The discovery dates back some 70 million years, to the Cretaceous period in southern China's Jiangxi province. The fossil consists of an incomplete skeleton of an adult oviraptorosaur crouched in a bird-like posture over a clutch of at least 24 eggs. A report in the Science Bulletin says at least 7 of the eggs are complete enough to have preserved the bones or partial skeletons of the unhatched embryos inside. Researchers may have finally solved one of Russia's great mysteries, the infamous Dyatlov Pass incident. The mysterious event saw 9 Russian hikers die in grisly circumstances in a remote forest on the snow-covered slopes of the northern Ural Mountains back at the start of February 1959. Something, or someone, caused this experienced trekking group from the Ural Polytechnic Institute to cut their way out of their tent and flee the campsite while inadequately dressed for the heavy snowfall and sub-zero temperatures. After the group's bodies were discovered, an investigation by Soviet authorities determined that 6 had died from hypothermia, while the other 3 had been killed through physical trauma. One of the victims had major skull damage. The other 2 had severe chest trauma, one with a small crack in the skull. 4 of the bodies were found lying in running water in a creek, and 3 of these had soft tissue damage to their head and face. 2 of the bodies were missing their eyes, 1 was missing its tongue, and 1 was missing its eyebrows. The Soviet investigation concluded that, and I quote here, a compelling natural force had caused the deaths. Of course, over the years, numerous theories have been put forward to try and account for this unexplained tragedy. These include animal attacks, hypothermia, an avalanche, katabatic winds, infrasound-induced panic, military involvement, or some combination of two or more of these. Tim Mendham from Australian Skeptics says Russian conspiracy theorists have focused on more imaginative possibilities, such as aliens or Bigfoot.
Sort of thing that goes back about 60 years to a group of hikers up in the heights of the Ural Mountains in Russia. And for some reason, they disappeared for a while, but their remains were found, I think it's about a month later or something, and some of them had serious head injuries, skulls bashed in. Others were sort of in a state of undress in the middle of the snow, and people couldn't figure out what had actually happened to them, so naturally everyone jumped in with alternative explanations, including yetis, abominable snowmen coming down and destroying them. They had tents, and the tents were crushed, and the people were outside in the snow. Or aliens coming down and attacking them. Really sort of, you drag in Occam's razor, and people recently have done investigations of what's called ice slabs shifting, and they pitch their tents underneath an overhang or near an edge of an ice sheet, because protecting from the wind. But the trouble is the top part of the ice slid on top of the bottom half of the ice, so a whole sheet of ice just came straight down. This is conjecture, of course, because no one was there at the time, apart from these 9 people. And when it came down, they rushed out of their tents or whatever, or got mixed up with the rocks and things that are in the ice flow, which causes the damage to heads and bones and that sort of stuff. And the people who were in this half state of undress were obviously trying to sleep. It was the middle of the night, supposedly. And also, there were parts of their bodies were missing. I think one woman was missing a tongue. And the suggestion is animals just come and eat the soft bits, which they always do, which is the same as the stories of cows being mutilated in America and they're saying, surgically removed intestines from cows. Must be aliens. No, it's more likely wolves. In this case, I don't know if it was wolves or what. But yeah, the avalanche theory accounts for basically everything about this mystery. In fact, the avalanche theory had been put forward before anyway, a few times. But this last time seems to pretty much clinch it. But certainly theories of abominable snowmen and aliens and whatever is clutching at straws.
What does it say about the human psyche that that's the direction we go in? It's aliens or it's Sasquatch or what have you.
Well, I mean, it's the classic thing, I don't know, therefore it must be. It's sort of the need to find an answer. And rather than just saying, I don't know, leave it at that, I don't know, but people don't want to do that. They need some explanation for things. Not knowing is a pain. So they have to find some explanation. If there's nothing else there, if there's no other evidence, for why something happens, you have to find something extraordinary to put it down to. So, yeah, it's basically filling in a gap in explanations and the need to have an explanation and the need to find a convenient explanation. I mean, if it's aliens, they fly away again, right? So they don't have to leave any particular evidence of their visit.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.